So now it's time to put together what we've learned about the z-curve and finding values for the z-curve in one big problem. So we're going to fill in the missing values, A1, which stands for area 1, A2, which stands for area 2, and then Z2, because there's 2 z-scores here and 3 separate areas. Okay, so let's start off over here. And you can actually start anywhere with these problems. I mean, maybe not the middle area, but you could start with the right tail or the left tail. It'll work either way. So it's just kind of whichever one you want to do. But over here, we know a z-score. We're looking for an area. So let's think about that with our Chapter 7 technology table. So we're looking for the z-scores. We know the z-score. Right, we have a z-score. We want the area. We want that probability. So we're going to use this, right? We're going to put the z-score in. And it's going to be pointing to the left because this is a left tail. So let's go grab StatCrunch. Here it is. I'm going to go Stat, Calculators, Normal. Now, again, because this is a z-curve, the mean is 0, the standard deviation is 1. That's the standard normal curve. And I want a less than because it's a left tail over there. And I know the z-score is negative 2.350, so I'm going to put that in and say compute or press enter. And I get 0.0094. Now I'm going to round this to 3 decimal places because that's what it asked me to do. It said right up here to give 3 decimal places. So that's what I'm going to do. So this value is 0.009. And let me show the work. It's the probability that z is less than or equal to negative 2.350 equals 0.009. And that was the answer we were looking for, the 0.009. Now, we need to find the middle area now. There's a couple ways we could do this, but remember that the 3 areas add up to 1 because this is a probability curve. And so therefore, I could just take the 2 areas I know, add them up, and subtract away from 1, and I'll have this one. In other words, if I take 1 and I take away the 0.009 that I just found, and I also take away the 0.115 over here, I'll have what it is. So I'm going to go grab Desmos to do that. All right, so here's Desmos. 1 take away 0.009, take away 0.115, gets me 0.876. So that middle area is 0.876. So I put it right here, 0.876. All right, wonderful. Now what about this right tail over here? Well, this time I know the area, but I'm looking for the z-score. So when you want to find the z-score from an area, you always put your area to the right of your equal sign, and when you press enter, it'll give you the z-score. Now, you can't pay attention to this symbol though, because the symbols can change, and this symbol will be a greater than because this is a right tail. All right, so let me go grab StatCrunch. Here it is. I'm going to make it point the other direction, right? I need it to be a right tail. And I'm going to go over here. I'm going to get rid of this area right here. I'm going to put in the area I know, which is 0.115. So that right tail should be 0.115. Then I click compute, and there we have it. We can tell that it is 1.200. Now, one thing to keep in mind is that the picture should look and match the picture that was on the page. So that right tail should match what's on the page. And remember that these 2 symbols point in the direction of their shading. So right tail looks like this, left tail goes like that. Right tail's like that. So let's go over here, and I'm going to write this in. So it was the probability that z was greater than or equal to 1.200 equals 0.115. That was the work that we put into StatCrunch, and this was the answer we were looking for. All right, so now we have to interpret. And when you do these interpretation problems, you want to pay close attention to what you're being asked to interpret, because that will affect the words you're going to use. So down here in the middle piece, we're asked to provide an interpretation of Z1, which is the left one, Z2, which is the right one, and the area in between them. And that's key, the area in between. So we would say 87.6%, because I'm doing this as a proportion. So we always start off the proportion ones by writing the area as a percentage. So 87.6%, there's not really a context for this. It's just z-scores. So of all z-scores, fall between or lie between z equals negative 2.350, and actually I don't have to write z equals. I could just say, right, because we said they were z-scores. There we go. Now it's very important, this is key, that you have a direction word. This is our direction word. Right? You have to be talking about a space, right? The 87.6% is this area in between. So you have to have a direction word that tells you it's between. You can't just say the two numbers, right? You have to have a direction word. All right, so let's do it again, but this time we're going to do it as a probability, right here. So we're going to do a probability one, and then it's asking for a different zone. So when you do these problems, you have to read carefully and look at what zone you're being asked about. In this case, we're being asked about Z1 and A1, which is this left tail bit. So if a z-score is selected at random, or you could say if you select a random z-score or something like that. If a z-score is selected at random, the chances it is, and then you have to get a direction word in. So we want to talk about the left tail. So you could say less than, lower than, below, right? Something like that. Chances it is lower than, right? There's our direction word. Well, in this case, direction words. There's two of them there, right? Lower than negative 2.350, right? Lower than that z-score is the probability, 0.009. The key with these problems is to make sure you pay attention to which direction you're going, right? Lower than, more than, in between, right? There are different words you can use, but you have to get it across that you're talking about a particular zone. And make sure you're paying attention to that. And then proportion way starts off with the percentage and then goes like that. And then the probability way always starts off with, if we select a random z-score, or if a random z-score is picked at random, or something like that, or a z-score is picked at random, something like that. Then we talk about that.